47 square, what is the remainder? Okay, so it's a very good question. Let's solve it. See, now we discussed this concept earlier of cancellation factor, right? Of cancellation. Means suppose if it is like 15 by 20, that remainder I need to calculate. So if I cancel it by 5, it is cancelled by 5, right? Like 5 3 ja and 5 4 ja. So cancelled by 5. So 3 by 4 remainder is always 3. Okay, 3 by 4 remainder is 3. But I should multiply by the cancelled term. I should multiply by the cancelled term called cancellation factor. Right, that is 5. I have cancelled by 5. Okay, 5 3 ja, 5 4 ja. So 3 into 5 will again give me 15 as the answer. Like 15 by 20, if I have to calculate the remainder, then 15 is the answer, right? Obviously, because the numerator is less than denominator. So in numerator we don't cancel anything, right? But if at all we need to cancel, right? If at all we cancel, so no issue. We can cancel here 5 3 ja, 5 4 ja. 3 by 4 remainder is 3. But whatever term I have cancelled, I need to multiply it back. Okay, so multiply it back by 5. 3 5 is 50. So 50 is the answer. Okay. Now, so 50 factorial by 47 square. Right. So we know that in 50 factorial, that is from multiplication from 1 into 2 into 3 into till 50, there will be 147. Okay. So let's cancel that 47. Right. I can write like okay. Because the concept here is, if here is 147 in denominator, then it is a prime number, right? So 46 factorial by 47, the remainder will be what? It will be minus 1. This is the concept, right? This is the concept behind this question. Okay, so it's like 46 factorial into 47 into 48 into 49 into 50. This divided by 47 square. Now this can get cancelled, right? Because they both have numerator and denominator. I can cancel 47. Now, remember I need to multiply it back. In the last. Always multiply the answer with 47. Always multiply the answer with 47. Multiply the answer, okay, with 47. You always remember. Okay, so now 46, so this question becomes like, okay, now 46 factorial into 48 into 49 into 50 divided by 47 remainder. This we need, okay? So now I know that 46 factorial by 47, what is the remainder? It is minus 1. Okay, 48 by 47, it is how much? It is plus 1. 49 by 47 plus 2. 50 by 47 plus 3. Right? So how it comes? It comes out to be minus 1 into 1 into 2 into 3. It is minus 6. So if remainder is minus 6 and denominator is 47, I can write denominator as what? I can write denominator as 41. So positive remainder is what? 41. What is the negative remainder? Minus 6. So for 5 minus 6 to the negative remainder and 47 as denominator, I can write it to be 41 and multiply the final answer with 47. The term which you cancelled, right? So 41 into 47. What is the answer? Answer will be what? Answer will be 1927. So 1927 is the answer for this question. Okay. So in remainder, whenever you cancel any term, at last always multiply it back. Okay. I explained this concept here. At last always multiply it back. Fine. Okay. Next question. Next question is 35 factorial by 74. What is the remainder? 35 factorial by 74. What is the remainder? Right. Now you have to observe this in this kind of question. Right? It is very easy question, right? But if you observe it, otherwise it becomes a very difficult question. So if you observe, it is 74 here. So 74 means and here it is 35 factorial. So 74 is not a prime number. Okay, and for 35 factorial, you have sense it like this. For 35 factorial numerator, the next prime number after 35 factorial, the next prime number after 35 is what? 37. So if it is 37, then 35 factorial by 37, that remainder would be 1 by Wilson's remainder theorem. Okay, p minus 2 factorial upon p, remainder is 1. So you can get here. Okay, but what I need is 35 factorial by 37. This is the USP of the question. If you get this, you can get the answer done. So you can like 35 factorial upon 2 into 37.
Wake up with a limited amount of discipline, and the more decisions you make, lesser and lesser it gets. And this is what.
Okay, what is this? This is Chinese remainder theorem. This is Chinese remainder theorem. You split the numerator, it is Chinese remainder theorem. So it should split like this, that both the parts are co-prime. Okay, so 2 and 37, both the parts are co-prime. Okay, now first part 35 factorial divided by 2 remainder will calculate, and next will calculate 35 factorial divided by 37 remainder. So 35 factorial by 2, what is the remainder? Remainder is 0, because 35 factorial is a big number. Multiplication from 1 into 2 into 3 till 35 divided by 2. So obviously 2 will get cancelled somewhere in between. So what is the remainder? Remainder is 0. Okay. 35 factorial by 37. This is by Wilson's remainder theorem. P minus 2 factorial upon P. What is the remainder? It is plus 1. Okay. So now it is by Chinese remainder theorem. It is by Chinese remainder theorem. So a number when divided by 2, remainder is 0. So number is of the form 2x plus 0. Same number when divided by 37, remainder is 1. So number is of the form 37y plus 1. Right? And we know that we did this in Chinese remainder theorem, that the first number, the smallest number satisfying this expression is the answer. Right? So you can directly observe it, right? Means you can simply observe it because it is 2. So left side is just 2x. So left side is just 2x. That means an even number, a multiple of 2, right? So at what value of y will I get as an integer? At any multiple of 2. So that's it for surely at y is equal to 1. Right? At y equal to 1, I'll get x as an integer. If I put y1 here, what is the answer? So answer for this question will be 37 into 1 plus 1, that is 38. So 38 is the answer. Even if you put at y equal to 1, you will get x equal to 9.